Today is my distinct pleasure to introduce Marko Rodin. It's going to be a free-form workshop, and he's going to be joined on stage at some point by Russ Grease. So Marko Rodin broke onto the scene several years ago and just has been making splashes and waves ever since then. He's a true seeker of knowledge and a conduit of profound knowledge. It's pretty amazing some of the things that have come from him. Literally hundreds of people around the world have now put in millions and millions of work hours and research into his work, and in the fields of health, in the field of energy research, and in the fields of consciousness. So without further ado, I'm going to turn this over to Marko Rodin. Enjoy.
Hi, everybody. My name is Marko Rodin, M-A-R-K-O R-O-D-I-N. My pseudo company is Rodin Coil Labs. And my voicemail and text is +1 858 255 1525. I have a YouTube channel. You should subscribe to it because that's really the only place I put anything. I have a website. It links to it. It's my name, markorodin.com or rodincoillabs.com. When it works. The YouTube channel, it has an about page. You subscribe. I put videos up. Sometimes I do live streaming. If you can't stomach mysticism, religion, paranormal psychology, altered states, the brain revolution, things that deal with the apex of consciousness, you won't like my work. My elevator card, my lead-in is over unity, 0-point energy, free energy. I'm appealing, forgive me, and I can be very, very, very abrasive, to the lowest common denominator. My word for what I'm offering is preposterous. If anybody to be offering free energy over unity, it's preposterous. No one can sell it because it's free. It's unlimited. And the first people that are going to come out of the woodwork that's going to appeal to are people who are greedy. So it brings the worst element into play. And of course, then there's the other individuals who are threatened by it, who want to control the spigot, turn it on and off, who want to be at the riverhead and dam it up. Probably the hardest thing to do in my life is to lead in as an icebreaker free energy. Because it's such a low-hanging fruit. It's so shooting under the target. It's just like God sending all his prophets down with what? On a Santa Claus sleigh. I mean, you're going to notice it, and you're going to recognize it. So it involves no diligence on your part. It's just like giving it to you on a golden platter, which is of no benefit to you, because then you're not exerting yourself in all the different ways that you have to mature and grow, spiritually, metaphysically, psychically, ethically, morally. Free energy is not a solution if you are not polished and refined enough to deal with it appropriately. That's the problem. The problem isn't the free energy. Many people have preceded me and come before me who knew these secrets. Usually their discoveries went to the grave with them because they wanted to have a nest egg when they died. They felt that their survival must be guaranteed their livelihood. And so when they died, all their accomplishments were lost. And that's why right now that's why the Australian Great Barrier Reef is over 90% completely bleached right now and guaranteed to die. Because the whole planet is in topsy-turvy, one way, shape, or another. Why? I'm not an expert, and I don't want to touch those issues. So I'm not trying to do anything that's going to slow down your spiritual personal growth. In fact, I want to make it as hard for you as I can. I'm a firm believer that no pain, no gain. I'm not trying to give you easy street on anything. Noted? Okay. The work that I had 3 or 4 things I cared about to present, and I'm not going to start with that because the video's ready. But I'm going to tell you and I probably won't even cover, I'll be lucky if I do any of them. One was going to do a hologram from micro to macro. Why the doubling circuit? A few of you know what I'm talking about, 124875. No one's ever seen how it is a 3D hologram. It vindicates my work because I want to say, my presentation tonight is, I could have said, this is written for the one I love. It's for the Netherlands, because the Netherlands has a wind that turns all those windmills. Are they called windmills? What are they called in your language? Molens. They're molens. Molen, and they have the wind. So I have found a wind. I have found a wind of eternity, a fountainhead, a spray, an unresistible, above the known elements emanation that only occurs in the center of the magnetic field. And when the magnetic field is going this way, the wind is going this way, and the wind's the source. It's the control. The people from the Netherlands are considered magnificent engineers, at least in the past. And my goal is to get this work there first into greenhouses, because their major product is flowers and fruits and vegetables it's very cold there. I want to see my work used for peace, and that's where I want to see it used first. I can light up a greenhouse. It can produce unlimited light. It needs no solar, no wind, no turbine, no batteries, no nothing. The video I'm about to put in is a quick synopsis of that. I haven't seen it myself either, for that matter, what you're about to see. Then we're going to do a live feed, a live stream. We're going to do it with a man that's very competent. He can build a robot and replace himself with the robot in a blink of an eye. That's Russ, who spoke 2 presentations earlier. And Russ is going to be our doubting Thomas. He's going to reverse engineer, dissect, rip and tear apart, and put back together again the Rodin Coil over unity energy amplifier, and verify for himself, does it produce over unity, and report to everybody. I have complete trust and confidence in Russ. The other things I would have done is waves of 9. It doesn't really mean anything to you what I'm saying. It's an illustration. It would have shown how I'm tapping to this energy. There's been a lot of criticism in the last week of me saying I'm doing Sudoku or I'm doing Photoshop. I got to live with it. That with the waves of 9, I'm showing Newton's cradle. You take one ball comes out the other end. It passes the vibration through the other 4 balls. There's 6 balls total. Mark Twain called that communicated agitation. if you take two balls, two will come out at the other end. Classically, that's called Newton's cradle. I found a way to do that with numbers. That's never been done before. But the profound thing is that I found that these numbers were passing energy. I call it a numerical interferometry diffraction grating. It's considered impossible. I also have my peer review from Microsoft. I would like, if there's time. They've given me a long time. They've given me a double session, 2.5 hours. I would actually like to read a single letter written from the Director of Advanced Operating Systems and his resume, who devoted his life to my work. If I had the funds, I would interview all the scientists, corporate engineers, professors who have devoted their lives to this discovery. It would take a year plus, because they've made such profound, huge discoveries and applications from biology to space power propulsion to computer science. That's the strength of this discovery. It's done, it's finished, it's ready to go out the gate. What do I do? Well, I got to go. If we covered all those things, there was one other thing, if I could do it too, is my ex-wife, mother of my twin daughters, Venus and Cloud, Heidi, wrote my first website, and only website. It's not up anymore. Jeff Rintz, the radio host, has it on his site. It's Roden Aerodynamics with 3 S's. It's only the first part. The other part that goes into Inagram, it's important, but it's the first part. I probably should sign out. No, don't mute it. Only sign me out of Skype on this phone here, please. But leave it on the iPad. You don't want to take it off the iPad, because the iPad's what we're going to put on the screen. We haven't done a sound test. If we have any problems, it's going to be audio. We'll have to live with it. I'm sorry. Anyway, Heidi's write-up explaining the torus and how it works is superb. It's only a couple pages. I would actually like to read that through. It may not happen, if it does or doesn't, but it really edifies and clearly explains how this works. Okay. What I bring to the table is that I've been able to take the binary code in computers and everything. I found the pathway that electricity flows in naturally. You don't have to force it. I get rid of resistance, reluctance. I'm able to make electricity super efficient. I actually get the temperature going down. I cool it with its own magnetic field. The coils you're seeing with copper are a toy. They're just a joke. There's so many other ways to make it. Solid state, screen printed, not the type of screen printing you're thinking of, but very simple ways. The cost for this is nothing. The tool up is nothing. The materials are on any shelf. They're not exotic. That's why this is significant. It doesn't take liquid nitrogen and cryogenics and capitalization. It's done. The models you're going to be seeing cost $250,000 in 2015 to produce. I didn't receive any of that money specifically. It went to overhead expenses, office people, testing equipment. My goal was to get a toehold, to get established with the university, have students, have a budget, because I need to delegate the work. I can't do any more work than I'm doing. And I'm drowning. I'm overdosed in work. And so I need a good staff, and I want to do a curriculum in the university. And the University of Texas at Austin is one of the most open-minded there is, and that's why I like it. And it's still high-tech. That's why I'm here in Austin. see if I've covered anything before we begin. There's last point, probably the most important point. The engineer that you're about to hear from, I'm going to call him 007. He's giving away his know-how, his skill set, and he's doing it up front. He's not, in other words, this is his nest egg that he's giving to you. This is an illustrious moment. This is a profound, big deal in all of our lives, okay? Because he's sacrificing himself, he's sharing the magic sauce, his skill, his know-how, the secret ingredients. I'm going to be asking questions if I think something's being glided over that's critical. The matrix, the lattice is critical. I predicted if this weaving, this geometry was made, this blueprint, the schematic, that from micro to macro, it didn't matter what the materials were, you'd get the same results over unity. If you had a million scientists, they would not replicate what he's done. He had just the right combination of abstract thinking, surrealistic personality, and engineering Geronimo to make it work. And that's why I'm here, and that's why it needs to be properly explained, because it defies and goes totally counter-directional to what any professionally trained electrical engineer is going to do. They would follow convention, what they're taught in the textbooks, what they learned in school, and this won't work. Okay, so let's start with this video, and I apologize in advance. If you don't think this is a rough presentation, then you can be a member of my board. So here goes.
Hello.
Hey, Russ. Nice to meet you. How's it going?
It's going well. Nice to meet you, too.
Oh, I heard that you were with John Hutchinson.
I visited John Hutchinson. I did. That was last April. That was an interesting trip.
Yeah, nice work on the fuel cells. Well, I didn't get it, but hope one day we will get it.
Absolutely.
The way that he builds his cells with all those components, it should be interesting.
Yeah, absolutely.
Yeah, but that's what it is.
It's a lot more work than some people realize, but one day at a time, as I say.
I know. I have experimented with some of those diodes that is using. Actually, LEDs, if you put it out in the sun, they can draw some power. Well, it's well known that semiconductors and this technology that he's using is pretty well known. I try it myself, and I can, certify that there's something in there. But yeah, it has to be furthermore investigated than it is right now. But other than that is really interesting, really interesting.
Yeah, absolutely. I'm interested in what you've got on your screen. Go for it.
Oh, yeah. Well, nothing special, I believe, really. I'm treating this coil as, as a wind turbine or as a solar panel array or whatever. Seriously, I get lucky because I was working with wind turbines a lot, and I'm sure that you have done it, I don't know, before. If so, you should know that like a 1 kilowatt or 2 kilowatt wind turbine, three-phase, out of the three-phase motor or an alternator, there is a lot of power coming out of that, especially, 600, 700, 800 volts AC. And it's pretty hard to find a controller that can handle, those variables from 0 to, let's say, 1,000 and AC. And I was working in this wind turbines, different windings and different shapes of magnets. And one thing that strikes me was that I couldn't find any step-down controller or DC to DC when you rectify it, of course, that could handle those kind of powers. Well, at least for small winds, I've tried it. A bunch of, I'm sure that the midnight solar, the controllers. Let me see if I can get you out of, I have my camera here, stick it on this, kind of, what do you call it? It's like a Velcro thing. And I'm sure that you guys have seen this kind of controllers in the past. They're solar controllers, MPPT controllers.
Yeah.
What they do is that they step down.
Turn
one,
Russ's mic
it's
up a little
common.
bit for me, please.
You can introduce 150 volts DC when rectified. And what it does, it steps down to your battery voltage.
The battery. That's what I was looking for. That's being charged.
Yeah, the solar solar charger's charging that battery and controlling it, maintaining it, etc.
Yeah, it can handle 30 amps. So I was treating. I'm sure that I have seen you in many videos talking with Daniel. And you know that these things exhibit a lot of high voltage, all of, Tesla technology, it's huge high voltage. And I was really, 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 curious that the market was not delivering, like, if you want to buy at 3,000 volts, at 3,000 volts AC or DC, let's say DC step down to a 12 volt, to 24 volt, there's not a lot of them. And I've burned like 6 to 10 of these controllers, Of course, when you have to, what I've done here is as you know, I have rectified the coil. I smoothed it into these caps, and then I have built this step-down control that can handle like a 2,500 volts DC to 24.
Okay.
It's what it does.
Hey, 007. Can we start from the very beginning of the incoming and work our way to the output?
Oh yeah, no problems. Of course. You know this setup. It's a frequency generator, of course.
Okay.
A generator and a frequency to the amplifier. This is an acoustic, a bass amplifier. So it's coming out of the amplifier is going to here.
Try moving the camera a little slower because it's more clear when it's more steady that way.
Oh, more steady this way. Okay, no problems.
Thank you.
So, did you follow? So it's coming out here, out of the amplifier.
A single phase?
Yeah, single phase. Yeah, single phase too. You can see it there. It's AC in. Let me throw out this light a little bit off.
What voltage is the amplifier putting out? Is that a high voltage amplifier?
No, it's a bass.
Okay.
A bass amplifier.
Yeah.
Yeah. Well, I use it to bass because I have seen. Back then I was seeing I think it was Greg I don't know if it was Greg Rowland. Greg Rowland. He was using a BH, this one, a B200H amplifier.
Got it.
Back then, and I was able to see it on the YouTube channel, and okay. So, but they're made on the U.S., so I have to, step it down from these AC to AC converters. What it does, it steps up.
Right.
From 110 to 220, and yeah. So, and this is going to. Well, let me get this out of the way. This is the from the. It's number one. It's the yellow one. It's hooked up to the input here, from positive to the negative of the single phase, and it's clamped over here also with this clamp meter. I don't know if you can see it. So pretty standard clamp meter. Just to
I see it.
cross what is the amperage, both analog. I got here the analogs also.
Yeah, good.
Well,
okay.
Yeah. This one goes to 60 volts. This is the amp meter that goes to a 1.5. It's too much of a light here. Let me control it. Let me see if I can get you guys.
Yeah, that looks better. That looks better.
Yeah, so as you know, this coil is powered. The input, it's also the output, right?
So there's just one. There's one.
There is no induction on this coil, really.
It's just one single coil all the way around, or is there many circuits there?
There's many. Sorry, I didn't get your question.
I was asking if there was a single coil configuration, one loop, or is it many coils, and some of them are shorted and some of them are open, or can you just explain the coil a little bit better? I know the math, but just explain it how you've done it electrically engineering circumstances.
Yeah, I can go through that. So he has an L1 and L2. He has, on L1, has the same number of conductors that on L2, L1 and L2. So it's 12 plus 12. The wiring between, it's different than Daniel's, really. It does not, he connects himself on L1, I have 6 conductors short circuit, and I'm using the other 6 on series.
And that's in the same single coil on L1?
Yeah, on L1. So the same is on L2. So they are, twins. They're really twins.
Yeah.
But I can, after this, I don't know if you guys have.
That's very critical.
After that, I can send you the wiring pattern.
Okay, yeah,
it's
good.
Pretty easy. Well, it's easy when you do it.
Let me ask you this question. You've got L1. Let's talk about just one coil. You've got L1. You've got 6 of those conductors in that single bundle shorted out, and the other 6 are actually connected to the circuit.
Yeah.
Okay.
Correct.
All right. Keep going.
So I've got, so to speak, I've got copper core in each one of them, right?
I'm sorry, say that again?
I've got what it is, I have got a copper core in each, right?
Yeah.
Because they're shorted.
Right. Right, I understand.
Copper core.
Yeah. Yeah, six of those 12 pairs are the copper core in what you're explaining.
Yeah,
I got
it. That's correct.
Okay.
And then, so then it's pretty much standard as Daniel did. Besides the way of that it's wounded, it does not as cross winding patterns. It's just one way.
Yeah.
It's clockwise.
And do you have 12 points there, 6 points there? 12 points there, because I know Daniel uses 11, which is not technically correct. Is there 12 plastic?
No. This is 11.
Okay, all right, okay.
Back then, when I was working, back then when I was not considered into the question, because I understand, people that understand a lot more sometimes don't answer silly questions. But on the beginning, Daniel was using 12. You remember?
He was using what?
12 frames.
Right, exactly. And in order to make this a complete circuit, you've got to use the 11, or else you've got to do multiple coils or some other configuration. So I understand that.
Yeah. But back then, I was arguing with them. Well, really, it's not that important. But if you wanted the perfect geometry, it's 11. When I was working, with a guy, a Russian guy, and he was really into it. And we were talking, and he was saying to me, hey, this is wrong. Let's try 11. Just to try, if the geometry comes, really better than because of the 12. What happens is that the wiring, you reach to a point that it was not perfect.
Yeah, you gotta jump to the next circuit and stuff to make it work. But this is just a single long bundle to make a single L1 or L2. I'm with you. Yeah. So keep going down the circuit for now, and then we can always ask more details. I think I'm clear on the coil. So you've got the signal generator going to the amplifier going directly to L1. And then L2 is connected to what?
Correct. That is correct.
Okay.
So I don't know if you've seen it before, but I have it here also. Around the coil, I have an AC probe.
Okay, yeah, exactly.
It's a loop.
Right.
Let me show you.
Is that just going to your handheld digital flute there? Yeah. Okay.
Okay, so this is where it's hooked up to.
Yeah, got it.
So then I've got here, of course, the other ammeter that goes into the input. Gotta go here. Wait a second. Let me just go here. Let's look up this one. Let's see if I can get you a good visual. All right. Let me get this here. This is the output on the capacitor.
What is that a capacitor for tuning purposes, or why is that there?
Yeah, it's for tuning. Yeah.
Tuning. You gotta have that LC circuit going according to your frequency, right? Okay.
That's correct.
Okay.
Yeah, a tank circuit. Yeah.
Got it.
Yeah. You gotta get that going. So let me get the camera on again. Here we go. Okay. So then we got the capacitor over here, and then now there is no load, right? Or it's not working.
Yeah.
The capacitor, and then I here have from the capacitor going to full wave bridge rectifier here.
Okay.
And then it's going to this capacitors. I'm going to show you a good visual on this. They are 450 volts to 220. Let's get this better one. Well, 220 UF microfarads. But they are all in parallel, so it's 220 times 8.
Right.
Right.
And then before you go on, what's the capacitance and the voltage of the other small capacitor you have?
This one is 2,000 volts DC, 2,000 volts at 0.15 UF.
All right, got it.
515 UF, yeah. It works with also this one. Let me get you the capacitor here. Wait just a second. Where is it? Oh. It works also with this one. This one is for motors.
Okay, yeah.
I'm sure you know this one.
Yeah, starting cap or running cap, one of the two.
Yeah. So this one, this one works really better.
What size is that one? It's hard to read on the screen.
This one is 450 to 500. He has a 2.5 UF.
Okay, cool. All right, yeah, run us through the rest of the circuit.
Okay, so we're going from the capacitors here, right, and going to the high voltage here, positive and negative. Now we have DC. This is, of course, you know that the capacitors just to smooth the signal. So, can you see it?
Yeah, it's you're just using them to smooth out the voltage, correct?
Yeah, that's correct.
And then that's your...
And that comes out of, let me get you this wire down here. So, this is from the capacitors to the high voltage here of the transducer, the DC-DC converter, step down, 24 volts. This one steps down to the 24 volts, and this accepts, this is from the controller, the wave controller, right?
Yeah, I see it.
So from positive and negative from the output of the DC-DC converter is going to this 150 volts DC max input, and then I've got here hooked up to, should I say from the controller to the battery, right, to a 12 volt battery.
Got it.
Yeah, so this is 12 volt, 45 amp hours.
Okay.
Okay, hope you can see.
What was the, tell me again what the DC-DC converter number was? You said it earlier, but I don't remember.
The DC-DC converter steps down,
what's the specifications, I mean?
Specifications is going, so,
No, I mean like the part number on the box.
well, the number on the box, there is no part number.
Okay.
I've built it with a couple of German guys.
Okay, got it.
They are from a wind turbine company. They have really nice skills, and yeah, what it is you can hook up a 2,500 DC input. That's your max.
Yeah. Okay.
On this DC controller, and steps down to 24.
Yeah, fair enough. I have a quick question before you go on. Right there, right next to the small white capacitor, are those little inductors on there, or what are those? Are those just for the meters?
Small capacitors.
Okay. And
What small capacitor?
Oh, I can't tell what they are. They might just be wire junctions, but they're right next to the white capacitor.
Wire junctions.
All right, okay, got it.
Yeah, wire junctions.
All right. It's just hard. It's hard to see. So I just wanted to make sure.
Oh yeah, I use a lot of them, as you can see.
Yeah, they're easy. They're easy to use. Okay, so
I use a lot of them. Yeah, it just makes it easy to make connections. Take apart,
right.
whatever.
Okay. All right. Well,
Good.
well, go ahead and fire it up or whatever you want to do. It looks good. I think we've got the basics down. At least I do.
So we are using 1.326 kilohertz.
I'm sorry. Say that again.
we'll fire it up.
What was the frequency? Couldn't hear it.
So at 1.3.
1.3 kilohertz. Okay.
6.
All right.
Yeah. So this is the on and off button.
I got
Right.
it.
If you had 1,000 years, Russ, would you have guessed to take 6 of the wires and short them out and to wind
here we
it,
go.
do that?
It's powered.
Probably not.
That wasn't in my original thoughts.
That's right.
Yeah.
That's right. That's
But
why
it
it's
makes
so
sense.
unique.
It does make sense, though.
Watch what it does.
Are you guys asking
Yeah.
any questions?
No, we're just talking back and forth. Continue.
Okay. Let's do it.
I'm musing with Russ.
Okay. So, as you can see here, now we've got, wait a second, what is going on? Let me power this a little bit up. There we go. Yeah. There we go. It's a little bit up. I'm trying to, have a really steady power here. So I powered it up. You can see it's on.
Yeah. I can
At
see
the
it.
inside, we've got 46 volts. Just to let you know that, well, let me turn it off again for you to see this. Can you see the amp?
Yeah, I can see that.
Can you see the numbers?
Yeah, 2156, and I believe that's AC amps.
22 amps.
That's 2,000.
Oh, 2,170 amps.
That's correct.
I'm going to bring it down again. I'm going to turn it off. So it's off. As you can see, do we agree
0
it's
amps.
off?
0.1 amp.
And just to clarify for people who may not understand, that measurement there is the loop going around the entire, all of the conductors from looping through the inside of the torus right there. Yeah, okay. I mean, I understand. I'm just pointing it out for other people who may not understand where you're taking that measurement.
Okay, so let me go. Let me see if I can. My goodness. Yeah, let me get. Okay, it's this piece of equipment here. All right, it's hooked up to there. So it's coming out of this. It's going to this because it's very long, and I cut it short here with some kind of code, and it's going there. So I'll fire it again.
Okay.
Okay, here we go. So it's fired. Right?
Yeah, we can see it.
Let's see the analogs.
You might have to dim your lighting some more. It's pretty
Okay.
white, pretty light.
Okay, yeah. So can you read it?
Yeah, it's, hold it steady. Maybe back it off just a tiny bit. It's about not quite an amp.
Yeah, right about an amp. To make sure that you guys were seeing that. And crisscrossing this one, this analog, it's right about there, the 50-something. Well,
About 55 or so.
we can see that there.
Yeah, 46.
It's 46,
yeah. Okay.
right? And this is the probe over here. Let me get the light on. Okay, this is the probe, the input side, right?
Right, we can see it.
Okay. So on the oscilloscope, this is yellow. The probe is yellow. That is on the input, and we're going to cross it here with number 1 there on yellow. It's 45.8, right about, yeah, the same, right?
Yeah.
This one says 46.
Yeah, looking at the voltage, yeah.
Yeah, let me go. Just
Your there's also an amperage measurement on your oscilloscope there, but that's not.
yeah, there is. I'm going to take them out.
Yeah, because the way you've got
Yeah.
it connected, it's just voltage measurement here.
Yeah. Okay.
Okay.
Here we go.
Yeah, I just want to clarify for everyone else too.
Yeah. So this is the waveform. So it's square wave, of course.
That's the incoming, right?
Yeah, up 46, right over there. So we'll now go for the amp. It shows on blue, right there.
Yeah, yeah, point it out. I want to make sure I'm reading in the right spot.
Okay. So this is blue,
Yeah.
and it says 800.
40.
Well, mean will be 850.
Yeah.
Right.
I can see it on the same channel there.
Yeah.
Okay.
It is.
All right.
So it's right about, and you can cross it with this one, and yeah.
You might turn your lighting down a little bit more.
Yeah. I lost control of because my screen goes off.
Okay.
I'm very poor at computers, and I'm doing this single-handed with the camera on the other end.
Yeah,
It's really hard.
what you're seeing right now, everybody, is not an easy task. This is the normal garage lab view tour that you get when somebody's doing something. They're doing too much. Get a tripod. It's very handy. Or a box.
We might as go here for the output now. And the output, of course, it's now okay. Can you see it?
Not really. It's still a little white.
Okay.
Contrast is too high.
Yeah, let me.
There
like
you
good?
There you go.
There we go.
So it's roughly the same as the input.
Yeah, roughly the same. Yeah, there is some losses. Sometimes there is a gain.
Yeah. Okay.
But of course, this was expected because there is no induction on this. It's just the same wire. Your output, it's the same wire as your input.
It's a 1-1 transformer pass-through kind of.
Yeah. And this is the output in volts.
Yeah. Can't quite see it.
Okay. Let me.
There you go. Yeah, hold it there and hold it steady. Okay, so we got about 250 volts approximately.
Yeah, a little bit less than that,
Yeah.
I believe.
Just a little.
And we will go here for this one.
215.
215, right. Now, what I want to do is probably, you want me to put the leads from the voltage in there? This one?
Yeah, on your scope, you mean?
Oh.
Or where you want to put it?
Oh, shit, it went down.
Adjust your headset for me, please, if you would.
Yeah.
Your headset's not that clear. Can you make it a little bit more clear for me, 007?
Wait a second, this went off. Everything's turned off. Wait a second. My goodness.
You gotta love those power strips. They always trip the darn breakers right when you're ready for it.
Wait a sec. What happened? It always happened.
This is what I consider live open science. This is it right here. You're viewing what I do sometimes on a daily basis, except this is more fun because you're watching, like right in front of me instead of on the internet.
I can solve this.
But like literally, people will talk back and forth like this with the live open science mentality. You guys, instead of sitting in front of me, can be behind the computer chatting. So
I tripped some breakers. Wait a second. I'll be back. I'm going to the circuit breaker house. This was expected also.
it happens to the best of us. Do 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 do. Shh.
Okay, Russ.
I'm listening.
You understand that the end result is that once it's daisy chained, we're talking about running like a 5-ton air conditioner. We're talking about 5 kilowatts, 10 kilowatts, 15 kilowatts.
It's copper wire. It should be scalable. So
And
I'm going to agree with you right now. But once
I gotta
again,
come back.
Your headset's a little bit muffled, though.
Validation.
Tell him to play with this
Grab
headset.
again, the circuit breaker out of the house was stripped.
Marco's saying your headset's a little muffled.
Oh, and now?
That's better.
Now it's better.
That's much better.
I gotta replace a fuse from this.
I completely understand.
Wait, I've got to replace a fuse from the amplifier. This was expensive when it got short circuit or whatever tripped. This has a protection on the back. Let me see if I can show you after that.
Yeah, always add protections into your stuff if you can, because replacing thousands of dollars worth of equipment is not
Let me
very
see if
pleasant.
I got here some other. Wait a second.
Yeah, so far it's looking good. So my personal goal is to verify this for myself with my own hands, because that's verification for me personally. This is a
Oh
good,
yeah, I got the fuse.
fantastic.
I was expecting this. It's a 2-amp fuse out of the,
Amplifier.
amplifier. Here we go. So, bear with me. Don't go away.
You want to charge that?
There we go in the back.
Live open science, my friends. It's
It's
a beautiful thing when you're working
Well,
on
it's
it.
always open. Well, let me turn the power supply off and the amplifier off.
You want to do real science, you got to be a patient person. You're doing well.
Yeah, but whatever. I'm gonna do it.
Okay. 007, you see the logo everyone see on his computer up at the top off the screen? It's pull your computer. Well, he can't.
Sorry?
Explain how the math of the funny, which I call the superliminal pictogram, or the mathematical fingerprint of God, that funny VW symbol, why you're doing this. Explain how what does my math, Vortex-Based Mathematics, have to do with this?
Yeah, just go. You got an emblem on your screen there, the Vortex map, and if you can just go through it, try to connect the electrical thinking that you have to the mathematical thinking that Marko has. We want to understand where you're at on there, I think.
Sorry guys, I was here, concentrated on this. Just did not make, any mistakes.
Don't
again.
mess with people playing with electricity. It's a bad
What
idea.
was the question? I didn't get it.
That's okay. The emblem there, right on your screen on your laptop, it's Marko's hieroglyph with the moving motion. Can you tie the mathematics to the electrical properties of what we're seeing? Like, tie those two things together for us.
Well, yeah. Basically, as I see it, it's this wiring pattern. What it does is it creates the best that I can explain it. It's an electric venturi. So if you pulsate any coil or any circuit, besides that, it's an enclosed system, right?
Right.
Which Eric Dollard refers it to, there's something that doesn't add up on a toroidal field, either because it's, a enclosed system. The way that I see it is that it draws or pushes, creates a pressure field. In this case, clockwise. Why did I choose clockwise? Clockwise is constructive, right?
Right, yeah. I can agree with that.
It is a constructive situation. If you go anti-clockwise, it's destructive. You can see it on Russell work, many others in the past as depicted this as visualize or experience these fields. So the way that I see it, it's drawing energy, or it's drawing the field towards the center and accelerating things towards the center of the coil, center of the torus. It comes back from the other side and is reintroduced again back into the system. So it kind of conserves the energy and gives the opportunity for you to have in this enclosed system a conservation of the energy.
Yeah, it's almost like this is a source where you're drawing in, you know, the ambience around you or something like that, where you're creating the space where the extra energy that's around us every day that we don't know about can be used in something.
Yeah, that's correct.
So can you tie it to the actual mathematics for us, or is that about the best? Like, as far as maybe if you look at the hieroglyph on your computer and just sort of.
Well, I just like that, you know, that book. It's the magnetic print of life. I'm sure, you know, you have seen it or have heard about it. What is that in that book? It says that, and confirms what Marko has always told us, is that, okay, you've got this patterns, these numbers, this number sequence that you can mimic nature. It's what it is.
Right.
So we are mimicking nature's great pattern.
So you've had some of this.
Sorry about my English, but
oh,
I'm not
it's
really
great.
used to.
It's probably better than mine. I'm still learning English 101. That's why I'm like stuttering half the time. So I guess right now the demonstration you've got set up, you know, you're charging a battery through a step down.
Let's fire it a bit up again.
Okay.
And hope that everything is okay right now.
Yeah, check it.
So it's fired up, and I would like to show you this. Let me see this. Let me get you to this.
Yeah.
Can you see it?
If you hold it really steady, I think we could. Yeah, 10.6 amps, 14.5 volt. I can't quite read the numbers on the far right. 150 watts I see there, correct?
150 watts. So
Okay.
that's dependent on your load, right?
Right.
You have
That's the
here,
output.
so this is frequency dependent and load dependent. But now you can see that the DC-DC converter is on.
Yes.
Everything is on again. So we've got at the output side, which is the input at the rectifier, going rectified to the DC-DC converter that's stepping down. I'm going to put you on the input side.
Okay.
Can you see there on the input side? It's stepping down from 200 to 20 volts.
I see the input,
Right.
yeah. At about the same
And
voltage.
I can go to this.
Oh, that's the battery. Okay.
Okay, that's the battery and that's the input. Now I can go to the other part of the screen because he has many, you know, screens, many displays. Now you can hear the fan turns on, right?
I couldn't hear it, but I believe you.
Let me go just here with a microphone. Can you hear it? The fan on DC-DC converter is turned on.
Yeah,
Because
I think I can
stepping
barely
down
hear
from
it.
An
Yeah.
high voltage, right? 250 at almost an amp.
Yeah, and why don't you show us all the meters again real quick, the ones you've got there.
Okay.
Just the
Okay.
input output. There you go.
So that's 46.9
Yep, AC incoming.
C incoming. At the amperage of an amp. Let me see. I lost the visual of the computer sometimes. So that's 1 amp, almost. Which we can crisscross it with the blue one here on the oscilloscope,
Yeah.
right?
Right.
And then we are going for the output side.
Yeah, so the input there is probably a little over 36 watts, if I did my
Yeah.
math right.
But this also is consuming, this frequency generator is consuming 20 watts.
Okay.
Of course, but we can go for a smaller circuit that consumes
Absolutely,
what? 1 watt,
absolutely.
1 milliwatt.
Right, absolutely,
No,
yeah.
it's just a signal. But I rather use this one because he has a bunch of,
Yeah, it sounds.
he has a bunch of situations that you can change.
Yeah. So go
You can
go
change
to
from
go to the
square,
go to
you
the
can do a lot
output.
of things.
Yeah, go to the output real quick. We'll do that quick calculation while I could just do it on the fly. Go back to the meters though. Use your meters.
Okay, so it's 215.
Got it?
Okay, at the same amperage.
Yeah, so that's about
I'm gonna turn off the blue one.
so it's about 172 watts out. So, and of course you got to calculate some of the amplifier stuff in there, but as a basic measurement, that's still a really big amplification.
Yeah, so now you see that the blue, purple is on, and you can see there the RMS mean. It's 800.
Is that on the same? Is that on the same scale?
milliamps.
That's not on the same scale as the incoming, is it? What's the? I can't see the cursors. What is the voltage set to on your input?
Oh, I can go with the probe there. Okay, let me go there.
Is it a times 10 probe or what is it?
What?
So your input voltage is lower than your output, and on your oscilloscope, I'm trying to figure out the scale on the actual grid on your oscilloscope. What's it set to?
Oh, I'll go through that.
Okay.
Okay. The scale is, so 1 division, it's 50 volts.
That's the incoming, right?
Yeah, incoming.
Okay. And what's the output there?
I'm going for the output now. I'm going to put the probe in there. Okay. Are you having fun? I have to use the other hand. Sorry. I've done it before. It's kind of shock.
Yeah. Well, don't mess up your
I don't want to
your
get
scope.
shocked. I mean, it's so high voltage in here. We know these things could and will shock you sooner than later.
Sometimes it's good to have a little zap, get a little fresh memory of what you should be very careful of.
Yeah.
As long as you're still breathing.
But
That's scary.
This oscilloscope only can handle 300 volts.
Yeah, we can see it though. Is it? And is your probe still set at the same times 1 or 10 or whatever it was at, right?
Yeah.
Okay.
Let me auto set it.
You got the current probe switched too, or just the?
I'm gonna switch now. So you could see now that it's 200 and.
Yeah, 12 volt. Yeah, 8
right.
volt.
Yeah. Kind of going for auto set here. It doesn't like this frequency at all.
Yeah, look at the outcoming wave. Look at what it's doing. It's pretty different.
You know, it's replicating the wave in there.
Right. It's like you're getting, according to the scope.
It's interference of some kind. I don't know.
Yeah. Okay. Yeah, I've seen some
Weird
strange stuff happen
this.
in my experiments too.
Okay, let me get this just D voltage. All right, here we go. So, here we go. So max, it will go to 213, which is really coincidence with the thing, the fluke meter, which is now off. And yeah.
So if you switch this thing over to the light bulbs you've got sitting there, is that easy to do?
That?
If you switch it over to the light bulb load, the inductive load, is that an easy thing to do?
It is.
Do you have to retune the entire output when you do that?
Yeah. Yeah. So it works at right about, no, it's just taking all these wires out.
Okay.
And you want me to go ahead and do that?
Yes, please.
Okay, no problems. I'll do that.
In the meantime, I'll sing songs. Y'all ready?
Real nice. Here we go.
Yeah, this is look at the output waveform though. That's very interesting the way it's like it's literally how many like it's hard to see, but it looks like at least 3 individual sine waves going on right there.
It's crazy. It's crazy. I don't get it. I never seen this before, really. It's look. Well, let me turn it off because I don't want to get, again, heavily shocked. So I'll turn the amplifier off. Here we go.
007. Can you hear me?
Well,
can you hear me?
Yeah.
So am I being too boisterous if I say that once looped and the final product, it can run an industry, it can run commercialization, it can run a hotel, it can run a manufacturing plant, it can run a home, it can run a boat, it can run an underground city? Am I pushing the margin? Can it go into outer space, and can you do a vegetable garden on Mars with this and grow and create oxygen and water and an atmosphere with this?
Yeah, well, you can do as much as you want it with this, really. What it is that, probably you might just scale it up a little bit.
Yeah, scale it up, sure. Have you attempted to put the input in the output? I mean, it's the same frequency coming out or close to it. Obviously, it's got some extras going on in there, but
yeah.
So have you attempted to loop it back? I mean, it's a tedious thing. Have you tried it?
I never.
Okay.
I never tried it. But I'm really tired.
Well, I appreciate the time you've given
I'm
us
really
so far.
tired. Well, along this, Marko knows the story and knows,
Yeah.
And you of course, Russ, you have gone through a lot, and this takes a lot out of you.
Yeah, it's exhausting, especially after you do so many things. It can be very exhausting. I completely understand.
It's a nightmare, actually.
You'd think when you come up with something amazing, people would be like, "Holy cow, let me add it." But that's sometimes not the attitude. So you got to work.
Yeah.
You got to have a big. You got to usually have a group of people with you to understand how to implement something sometimes.
Definitely.
Yeah, you can't just throw it out
there. This is not an easy task.
No.
And I have to work also.
Yeah.
And I fall in love with this technology, really. Basically because of you guys, really. You, Daniel, Marko, of course, the big reason why I'm doing this. So I've been striked by...
And Randy Powell.
Everyone. Randy,
yeah, there's a lot. There's so many more people out there that you have even time to recognize. The list goes on and on.
Yeah, the list goes on and on.
We're all in the same boat.
Jack from Hawaii.
Jack Schultz, good old friend.
Yeah. Well, I missed here the voltage thing. Here we go.
So when you retune this, you're only going to retune frequency. You're not going to replace any caps or anything like that?
No, not really. This cap works better. Works really good.
Yeah. So you took out your other cap bank. That was just for smoothing it out for the DC-DC converter.
Yeah.
Right?
all of you went there.
So right
That's-
now, the light bulbs are actually going to be seeing AC according to the
I see,
oscilloscope.
yeah.
Okay.
I see. Let me go just here for a clamp. I broke a wire.
That's better than breaking pipes. That's a mess.
Yeah. You know, all weird things happened.
So I've been
When
stating from the
this
beginning,
live.
my position is it's ready to go out the chute. It's ready to go out the door, that it's ready to go into production.
So, here we go again. With this.
Or
Am
at least the basic model is here, and it's something to work with because a lot of people don't get this far. It's a challenge to get this far. To actually see
Yeah.
something with the meters set up and you're seeing something. And so a verification for me personally would set that off for me. Like that would be the verification. This is amazing. This is very interesting to me. But my personality is I want to do it with this. And then I know what I'm seeing because I did it. So this is the way to do it, by sharing. So sharing is caring.
Yeah.
Sharing is caring.
There
really
we go.
is.
Let's see. See if you got here another frequency around.
Do you remember the frequencies you've tuned this stuff at? Or do you have to find it?
Probably 700 something. I don't
So can you
really-
briefly I understand in normal terms why you're tuning it, but maybe in your own mind, can you tell us how and why you're tuning it?
Well, it's obvious because
It's
now your
it's
load,
it's obvious for you and
different.
me, but it's not obvious for a lot of other people.
Okay, so when you got to circuit and you're changing your load or work being done on the output, what it does is that because it's a different load, you have a different frequency. It's like let's say if you're using a Wi-Fi password in your house, if you go to the bar, you have another frequency there or another password there. So it's kind of the analogy for people that don't really are familiar with this.
Electrically
It's really,
minded.
if you change one, you change the other.
Yeah, so the idea here is you've got an LC circuit set up, and an LC circuit's the basic principles of Tesla. It's his baby, really. And it's the way I've seen, it's resonance is what it is. And resonance in my mind is one of the ways to get to, may have just be a part of, but it's one of the ways to get to this sort of over unity, if you want to call it that, this amplifier. An amplifier is a good word. Tesla had the Tesla amplifier. He didn't call it a Tesla over unity tower or something. It was an amplifier. It's amplifying the ambient around us.
Yeah.
It makes sense to me anyway. As I understand it now. I can always change my opinion.
Yeah, of course. So let me see. I don't quite remember what was the frequency, but we are going through that in a second. Let's see. Let's see if you can. So it's right about 1.2.
What wattage and voltage are the light bulbs, and how are they connected? And how
Well,
many
they
are there?
connected in series and parallel.
Okay.
Series and parallel connection.
And
You have your maximum output, both amperage and voltage.
Got it. So do you remember the inductance of the coils?
I do remember the resistance. It was probably 13 ohms,
Okay.
right about that.
Okay. And I know you said this, but what size wire are you using there?
Yeah, it's 0.56 mils.
Okay.
I don't know what the gauge is.
Fair enough.
I think the section is 0.56 millimeters, right about that region.
Fair enough.
Yeah, so we're now hooked up to the output. So let me get you this wave over here. Okay. So we can do it again.
So 007, am I accurate in making the pronouncement that this is capable of eliminating nuclear fuel or petroleum fuel because this is another new form of energy?
I think it's not a new form. I think it's a rediscover of, nothing is new in your work or in our work. I'm not saying in yours, but you, I, Russ, and other people, we're except Nikola Tesla. He envisioned, he has really vision problems. He saw machines in front of him, pretty clear. But we based our work in others, right? It's a piece here, a piece there. You gain experience from that, there, and there, and you put it together. But yes, we already have a technology that can obsolete petroleum, which is solar, of course. And this is no different. This is a renewable energy source. And it's amazing how easy it is. Luckily enough, I'm not, I've become sort of an electrical engineer. But the way that I see it is that, is a renewable energy source. Now you can see now, and Russ will identify this really, accurately, is that you have a phase shift. Now, despite the other situation, let me go this.
The phase shift is just an added bonus in this case, huh?
Yeah, so you have here a phase shift between voltage and current, which is not good, but it's okay because you're using an inductive load, and this is, the power factor will be compromised by your phase shift. Phase shift is that current or voltage is leading or lagging. It's arriving first or arriving before one another, right?
Right.
This is what you call, it's not a reactive load, it's not that, but it produces a lot of reactive power, which is the non-active part of your energy, because you have two components, which is apparent power, the other one is real power, and you have also the other component, which is reactive. Reactive is something that you will not use, only active power. But the way that you see this, let me go just, the way that you see this, it's, we know that current, it's over time, right? If you're heating, let's say if you turn on your heat, only a few minutes before, after you turn on the heater, you will become hotter. It's like this system. The way that I found that we can see if actually power is being done, it's with a thermal camera. I'm going to get to thermal here, but it's not working at it's not working quite a while now. But let me turn this off. Just let me get the camera.
Yeah, when you get there, talk about some of the temperature gradients that you've seen. I know you've got an IR camera set up, which is another useful tool. You've got a lot of useful tools here, so this is good.
Okay. And then you can see on the PDF that I sent to Marko.
Yes.
The heat signatures, because standard standard technology or standard, electrical engineer will tell you, okay, this is active, this is reactive, this is that. Now I wanted to see if there is heat, there is power. There's
photon radiation.
Yeah.
Wastefulness most of the time.
Can I interrupt for a second,
Yeah.
please?
Waste is most of the
Am
time.
I allowed to
I
grab a
don't know
minute?
if you guys can see this, but I will make
Absolutely.
an attempt.
007, can I grab everyone's attention for a second? When I designed this coil, I designed it as a space power propulsion system. It's supposed to be creating implosion at the top that compresses and then decompresses out the bottom. It's a one-way positive stemic flow that implodes and then explodes. It compresses and then decompresses. And I designed it to go anywhere in the universe. It's hard to fully realize that that can be an engine for a spaceship, but that's what I designed it for. I can go anywhere in the universe and never have to return back to Earth for fuel. There's no payload for fuel.
That is a true possibility here. There is a true possibility here.
All right, if you got that thing all tuned up, I guess really quickly before.
Let's fire it up. You want to fire it?
Yeah, just show us the input-output with the light bulbs connected.
Oh, let's do it. Okay.
I think that verification, and after that, I think
Yeah.
fair game for the moment.
Let's do it.
It looks
so
good
now
visually
we got
for me.
37.3.
Yeah.
Then we go for the analogs. Now we are over an amp. Let me get this. Okay. I have to put my hand on here just to cover the blurry. No, I'm not having success.
There you go.
Okay.
So we're at about 1.25.
And the voltage, well, it must be coincidence with the digital meter. It's right about the 40.
Yeah.
Almost 40, which is the 37 around here.
All right.
Right?
We can see it.
We are now hooked up to the output, really. Let me see. That's the output. Your output now?
Yeah, so okay. 1.25, just over 1.25.
Yeah. And that's your output in voltage.
So here we're at about 110 or
you
so.
You have here.
Yeah, okay. So
109.
that was 40, if I remember right, about 46 watts in, 137.5 watts out. And
Yep.
for me, verification with a meter like that and not the digital meter is better verification for me. I trust the analog value. Obviously, you need to check it with the oscilloscope to be 100% accurate.
There we go.
I shouldn't say 100% because we're measuring a wave in a one-dimensional space here, two-dimensional space, which is wrong anyway. But it's the best tool. It's the best tools we have to measure what we conventionally understand.
So this is your oscilloscope readings.
Got it.
So it's 1.15. It's the purple, right?
Yeah, at about 112 volts. It's about
112, yeah.
128.8
And that's
watts.
your waveform.
Okay, so switch that thing to the input real quick, and then
Okay.
we can do whatever we need to.
All right.
Anyone else got any
input.
questions? Let me know. What did you set the frequency for the light bulbs?
The frequency is now 1.226.
All right.
If you go down, of
Kilohertz.
course, that's what happens. I'm going down. Can you see the lights over there?
Yes. Yep.
So we've gone out of resonance, right? Now
Yes.
we have out of resonance to one kilohertz roughly. And here we go again.
Before you bring it back in, or why don't you show us the scope while you go in and out of resonance, just so people can see, what we're actually looking at here. So there you can see the voltage and current dropping down. Resonance is very important, especially in this, especially here. You can actually see tuning that frequency in is key, which is what Daniel Nuez was doing for a long time, and not too many people really went at it. But this is the basic principles he was doing as well. And yes. Yeah, about threefold, I think. Three to four, but okay, go on.
Yeah.
The potential here, according to what I am visually seeing, without touching and feeling and actually, doing it by myself, that is a correct statement. We are seeing a device that has a one input and a 3 to 4 higher percentage output. Yeah, so according to these meters, which there's no reason to not believe these meters. He's got digital, he's got analog, he's got the oscilloscope. Those are the three main components that any really good scientist, engineer needs to verify something like this. There's always questions and concerns, but you're seeing what I'm seeing, and I'm seeing something very extraordinaire, very interesting, something worth looking into. Yeah, I mean, if you can run a light bulb and in an inductive load, or in this case, a resistive load, that is true power. Most of the time, that's true power. You can't necessarily fake true power with that type of load. With the with the DC-DC converter and the other converter and the battery, it gets more complicated and confusing, but this is just a signal in, a voltage in, a current in, a voltage, current, and signal out, and an actual real-world load. You can't get any more basic than this. I don't see, there's no exotic materials here. You could potentially do this on your own with no machinery if you know how to make copper wire, make the dies. I mean, in theory, you could build this whole thing with just stuff that you could find around, which is not an easy task. Most exotic materials and high-level scientists are doing things with exotic materials, and it's like, how am I supposed to get that? You can't. You can't get that. So that's why this is fundamentally important in my viewpoint.
Yeah. I can show you some exotic materials.
Yeah.
And
I'd like your question to be into this mic. Any questions, please come up and take the chair if you have a question.
Take the chair.
And I'll throw the switch.
Okay, Russ. I was a little bit concerned about,
Russ, you have been around.
Something
Hold on,
important.
hold on, 007. Hold on a second. We got a question.
Okay.
We got a question.
You have been around. You've seen a lot. Have you seen this? Is this significant? Have you seen it before, or is this just a 1 in, 4 out? It means that it's there, but
That's a good question. Let me trade you back. So that's a good question, and what I can tell you is I've seen a lot of people claim stuff like this. I've spent my entire research 8 last years doing nothing but watching a YouTube video such as this, and then attempting to build it for myself and verify it. And to be totally honest, I haven't had any good luck with most things I've done. There's a few things that are intriguing and I want to continue, but I haven't really got to this success level. But I can tell you that when Daniel Nuez was doing this principle, he was showing these things with the things he had available. He didn't have an oscilloscope at the time. He had some meters, and they were just digital. He didn't even have analog stuff, and I had a hard time believing that because meters can lie to you. I've learned the hard way, meters can lie to you. You have to really know what you're doing to get this good accurate measurement. That doesn't mean you can't build a coil and make it work. I'm just saying to take the measurements, you have to have a lot. So to answer your question, this is, for me personally, this is something that you guys should really pay attention to, and you should look at. And if you see me post a video of the same results, you better start paying attention, because this is significant. I cannot guarantee a time. I have 5 children, 6 is the oldest. Don't push me. Don't push my wife.
Kind of a follow-on then, theoretically, someone could build this and basically get a 3.5, 4-fold output from the input, and or stated another way, basically reduce their electrical bill by 2/3, 3-fold, something like that. Assuming they could build one, scale it, and make it work, and hook everything up correctly and all that. Or create some induced or maybe a commercial application where they made something that would connect to houses and therefore reduce the power load on the grid. And
Yeah, I mean, for me personally, the ultimate thing was just make this device function, even if I had to run it from a battery or something like that, because
yeah.
I can always take a solar cell and run the battery. So I
oh,
personally,
okay, so
I
then
personally tend to
you
stay
got
away-
more or less free energy at that
I
point.
personally tend to stay away from any grid input at all if I can avoid it. Now, what I will tell you is that, and I asked 007 here. I said, "Did you loop this thing?" That's the ultimate. And to be totally honest, which I always am, I don't know if you can even loop a device because of how it functions. There may always need to be energy conservation through the whole system, but when you actually close the loop, if it's a proper device, you would think it would work. But the way we don't understand this universe, I have a feeling that might not be the best way to go about it. It may be better to take a conventional energy, run it through an amplifier, and conventionally use it. 100 years from now, maybe we don't need conventional electricity, and I can just charge my mind with, radiant energy.
Yeah.
That'd be great. Forget the coffee. I don't need it. But, I mean, so in my viewpoint, to answer your question, that's the basic principle here, is to down your energy bill, whatever you need to do. In this case, I personally would just go straight to buying some cheap solar panels and make this thing work. What most people don't understand that I'm learning is when you can live really basic.
Yeah.
Well, can't you grow your own food? What do you really need your cell phone for? You can run some candles if you want. I mean, if you go back that basic.
Yeah.
So if you wanted your cell phone, you create some simple devices, you live basic, you're good to go. If you want to live in the lifestyle you do now, you have to build a lot of these, possibly, or make it bigger, whatever the case may need to be. But yeah, that's the ultimate goal, is to produce energy and not have to be concerned about anyone else around you or the big guy on top of you or whatever the case may be. Yeah.
And if you're looping it, then basically you're saying that it becomes self-sustaining at that point.
That's right. And I've just had experience with, playing around with the idea of looping because I actually have 2 of these coils sitting on my desk. They've been there longer than they need to be. And so looping this is something that I could try, but I just know that from the people I work with, the people I've talked to, the thing about it is it's a very difficult task, and I just think that has the way.
Can I jump in?
Oh, the loop, you mean?
The way the energy.
Let's
thing
just get it
works,
working first, and then.
But
go
the
from there.
amplification part.
Well, can I say something?
Yes.
Sure.
Okay. I think I have experienced it before. I think it's possible to loop it, really. I think it's possible to loop it. But you have to have the right equipment to do it. Because it goes back to the principle where this DC to DC converters operate on. It's like LEDs. Between the anode and cathode, you don't have a single physical connection, right? That's how this DC high voltage DC converters are built. They're just connected by a single diode, or minimum interference between your input and looping. Let's say if we go right here to an inverter, let's say a 12-volt inverter, 800 watts, whatever.
Right. Straight to an inverter, yeah.
You just have to make it properly, that one system doesn't interfere with another. Minimal interference, really.
And that makes sense. I think we've got less than 10 minutes. We've got about 3 people wanting to ask questions. So I guess before I let the questions go on, I have to ask you one more question.
Okay.
We don't have a schematic. Just briefly tell me, the coils, we know that they're short. 6 of them are shorted out of one bundle. But are the other ones run in parallel? Or are they...
Series.
In series, okay.
Series.
All right,
In
cool.
order for us to have high voltage on the output, you must series. You
Okay.
must, each series connection will give you a ratio in voltage, and if you go, as you know, Russ, if you go up on voltage, the current must be accordant.
That's right, yeah.
To that, so that's Ohm's law, right?
And and that's L1, L2 both connected identically, right?
Yeah.
Okay.
But the thing here is that this is different from a normal transformer, is that on a regular transformer, you don't have the L1 and an L2 connected to your power source.
Right.
You don't have it.
Okay.
They work by induction. So L2, it's induction, it's harvesting energy from your ferrite core or from your iron core.
Right, exactly. Or the
right.
the change in magnetic field, really.
Yeah, right. So here, there is no losses because of that.
Yeah, it's because
your
it's an air.
input,
Right.
It's your output. You're conserving the magnetic field because that's what important. It's your current. Do not lost your current, because voltage you can step it up. A boost converter can do that on a DC ratio, or also in a transformer AC currents. But when you conserve your this input source and channel it into your output source, it's totally different. It's totally different.
Right, yeah. Yeah.
Because induction, by definition, is losses, right?
That's
if
right.
you're inducting,
Usually in heat. That's why everything gets hot. It's that principle. Okay. All right, I'm gonna take a few more questions. I think that's good.
Okay.
Okay, speaking of temperature, which you just were referring to,
Okay.
we've seen with other, historically, other devices like Floyd Sweet reported a drop in temperature when he went over unity load. Can we track that? It seems like you have the instrumentation to do that, so just comment on that.
So 007, I don't recall from the PDF, but I know it's in there. You saw an actual negative drop in temperature in the center of the torus. Is that a correct statement?
Yes.
Okay, that's it. Yeah. And so the longer it's on, the lower the temperature gets, obviously to a point, right?
Well, obvious, and you can automatically, refer that to anything from a tornado, from your water going down the drain. So it's a lower pressure, right?
Right.
If you're spinning something on a toroid fashion, let's take, for instance, the measurement of the PSI pressure on a tornado. At the very center, there is a significant drop of pressure, right?
Right.
So if there is a drop of pressure, there is a drop of temperature, right?
That's correct.
So,
and for most people who don't know, that's a lot of people dealing with Tesla stuff. They see that they call it cold electricity, but it's literally like it's a colder environment because of that. There's lots of technologies that have that. Okay, and by the way, we're good. I think we got one more question. But by the way, the PDF that we're talking about is on Marko. It's on your YouTube channel. So I'll let you tell them your YouTube channel, but it's out there. One more.
I have a question for 007 and I have a question for Marko. But I would mention I've run scalar signals through these wire coils and appear to be creating singularities, and it is endothermic. So I agree with what 007 is saying about that. So 007, simple question, what's the gap space on the coil?
E gap space?
Yeah, between the wire twists.
Oh, wait a second, I will tell you that. Let me get the ruler here.
Good question. No gap space, no results.
Yeah, and also give us just the general dimensions of the coil there, just so we have them, since you got the ruler out.
I will do that. Wait a second.
While he's measuring, Marko, you also mentioned that these wire coils are essentially like toys compared to other materials and methods you've used. Can you talk a little bit about what materials and construction techniques of other coils?
The gap space is everything.
Gap space
I have a
is
video that BJ has done for me.
0.9.
Gap space is 0.9
Inches,
What is that? You metric
millimeter.
system. Millimeters.
millimeters.
In a milliliter.
Yeah,
0.9.
And then
0.9 centimeters, then?
you're talking about centimeters,
Millimeter.
millimeters,
Millimeter.
millimeters.
0.9 millimeters? It's got to
Yeah.
be centimeters.
It's got to be.
0.9 millimeters. So it's roughly almost 10 millimeters. So
Okay.
it's 0.9.
0.9 centimeters.
That's in centimeters, yes. So I can go here for the conversion table in
That's all right, we got it.
meters.
There's a gap space. The gap space is always in the center. But there's also what is called a boundary condition or a shear on the outskirts. It's
So
too complex for you to understand how it's being created.
the coil is 7 centimeters wide. Wide, sorry. It's 27 centimeters. Yeah, 27. And on the center, we have 9 centimeters on the hole here.
Okay. Well, I think we lost your video, but we got it. We're good.
Is the
Okay,
gaps,
let me-
is the gap space, Marco, related to the degree of the coil twist?
No, in fact, I don't incorporate that twist in the accurate design. This is a variance, this design.
Yeah, 'cause
There's, go ahead.
You've got so according to, if you want to talk about math directly only, you would have a single gap space with the 2 copper conductors right next to each other, but then you'd also have 12 of these holders that you're seeing, the black things holding the wire in place. But you use, in this case, it's easier to use 11 just because of the way the wire wraps the torus.
Right.
But to do an actual pure representation of math alone, which I've done myself, but not in this configuration, it makes it more challenging. So it's like if it works and you can make it easier, do it. This is sort of that. So this could potentially be 1% of what you could get when you do it to the T.
Gotcha. Just
What's
follow
your-
the math.
What's your first name?
Ken.
Hi, Ken. Okay, can I take the floor for a second?
Absolutely. I think we're.
Ken, stay put, though.
Do you wanna let him go? You wanna leave him on?
Huh?
Are we
I
good?
want to leave him on.
Okay.
Can you hear me? 007?
What?
I'm saying hi.
Hi, how's it going?
Good.
I'm here.
Okay. First of all, it's what time a.m. where you're at? It's not that late, but it's pretty late. What time is it there? Well, I'm
It's
glad you're not sure.
Almost midnight.
Okay, thank your wife and your family and your cat and everyone else for letting us run you into the ground every day.
Well, thank you for having me and to have the opportunity to show this to you. And it was a big pleasure to talk with Mr. Grease at last.
The same right
Yeah.
back at you. It's always fun. I enjoy this type of stuff. This is what I do on a daily basis through the interwebs of live open science. It's a lot of fun.
Yeah, not a lot of fun when we burn $1,000 of equipment or 1,000 years, or either if you burn an oscilloscope, 10,000.
I agree on
Well,
that.
It's not funny. You've seen it. I have to change, but everything went bad. But it's what it is. It's live.
I'm going to make myself last. So I'm going to still let you all speak and take the lead. So 007, if you were making this out of exotic materials, if you were making it out of carbon or some other bizarre thing like magnesium, or if you were trying to make it chemically.
Can I just show you something?
Please do. Take it up. Take it up 1,000 notches.
that I found here very interesting. Speaking about exotic materials, let me see if I can get this working for you guys. Wait a second.
He always has a dessert at the end.
And show you something really, 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 really significant.
You better add sugar to that. I run off sugar. Shh, don't tell
You're off sugar?
I run off sugar.
You run off sugar?
We have.
I got my question.
We know that Ohm's law.
Yeah.
If we increase the temperature on a conductor.
We lost your video. Bring it back.
Okay.
Got it.
If you have temperature rising on the conductor, Russ, and I want you to ask this question: what's going to happen to the resistance when temperature goes up?
It's going to get more resistance.
So resistance will go up.
We lost your video again.
Why this video is turning off all the time?
Because it's Skype. Sorry, Skype. I love you. Just kidding.
I thought it was my camera. Let me get to this. Wait a second.
So he said with increase in temperature or entropy, you have heat, which is collisions, which is reluctance, which is friction, which is
movement. It's the whole principle why a superconductor works. It doesn't have to. Most of the time they're at cold temperature because of the Bose-Einstein condensate, which in this case is the opposite when you go high temperature. So that's why whenever things get hot and you're working with electrical systems, the efficiency goes down. You got to check your efficiency when the system's hot. That way you know really where you're at too sometimes. If your system gets hot, hopefully it gets cold.
So 007, what are you showing us?
Wait a second. Let me set this camera here for you guys to have a perspective.
Well,
on this.
You've whetted our appetite. What kind of materials, what's it going to be made out of that you're showing us? What's the compound or what are you about to show us? Give us a verbal explanation in advance.
This is graphene.
I was going to guess paralytic carbon, so I was pretty close in my mind.
Yeah, that's it. It has a layer here. It has multiple layers. You can see it's a kind of a paralytic graphite, or, well, it must be graphene at this point, of course.
Structured
I'm going to show
carbon.
you the resistance on this.
Yeah. Well, you just said it in a completely different way, so you don't have to worry about looping it then.
So you think I'm going to hold it steady over here.
Move your meter back down just a little.
Wait, let me get this here.
This is all part of live open science.
I got to increase the angle in order to go and show you this.
You know who we should have thanked too, even though we forgot him because he's been low profile? We should thank Jamie too.
Absolutely. I bring his name up when I speak about Vortex Math because he's a pioneer.
Yeah.
So I'm sure that you can see it now, right?
Yes.
It's right about
1.6. We can see it. Now heat it up.
Okay.
I want to see it go down. Yeah, I can see the light below. So.
Wait. Let me increase it on temperature.
So you know our next commission is to make a spaceship.
Wait a second. Wait.
I was gonna say,
Shit.
you might have to try heating it on the side or something, some weird structured lattice thing. Crystals are great.
Ah.
It's hot. This is why live open science is fun. See, don't laugh. Okay, laugh. That's the best part of this.
Okay, I'm gonna start.
There it goes. So what'd you do, flip it over?
No, just increase the surface of the heating.
Okay. That's completely not the way you would think of a normal heating problem. So we know, I know anyway, graphene and graphite and paralytic carbon, they're all very interesting property. It's just what I work on at work is quasi-crystal based principles, and it's this type of principle. It's very interesting, exotic stuff. Paralytic carbon and graphene, I mean, carbon is the most basic thing around. You just have to know how to turn it into graphene, and it's pretty incredible.
So you've seen it.
Hey guys, we're running out of time here.
Okay. Hey Russ, I got your nickname.
And
Dr. Strangelove.
Oh, I'd rather just sign my name, Mr. Open
And
Source.
it works better when you going and do electricity and going in transmitting electricity through it. When you go to high amperage, it drops on resistance heavily. I mean, it's the opposite of copper.
Say it one more time. Say it loudly, and then we're going to say goodbye. That deserves saying twice. Say it again, please. And what is causing it to do the reverse and opposite of science and physics textbook knowledge today? You're saying what again? And why does this happen? Is it going through the circuit or what?
Well, if we build our circuit with this material, with the coil with this material, you know what will happen, right? You will, put 20 amps, 30 amps, 100 amps, 200 amps on this, and the efficiency will go up dramatically. And ultimately, what graphene does, because it's a honeycomb structure, you've seen it, you can Google it or something, goes back to your map, really. If you map it and if you see the carbon, oddly enough, the carbon is 6. And if you go to the periodic table, lithium, I think, is 3, carbon is 6, and 9 is 4.
So people would become their own power plant utility. That's what you're saying.
If you build the coil with these 3 materials, I wonder what happened. No input.
No input.
No input, yeah. At one point you will disconnect your input, but you still have to have, for this to happen, for these effects that you've seen, it must have an input.
Eventually it will be a closed system, because my math says that it's a closed system.
Yeah, so. It could be. It could be. But there is a very nice machine that can build nanostructures in Germany. I've seen one.
Okay, you have the closing. You have the closing remarks. I'm done. Russ is done.
I've had a pleasure. Thank you both, and everyone else here.
Okay.
So I think we're good. I'm good. I appreciate it. This is a little snippet for you guys that's never seen this live open science reaction. This is great. This is a perfect demonstration for you to see this. So it was a pleasure that I got to do this. Thank you.
Thank you, Russ. Thank you, Marko. Thank you, guys.
Marko, did you have some closing remarks? You said you wanted to wrap it up.
If and whoever comes back, I will go into the ad infinitum tedium of explaining why the base 10 system is not one system. It's 2 separate systems. The separating of the 1,2,4,8,7,5 from the flux field of the 396. And once you separate them, you can do any calculation in the universe. You get rid of endless non-repeating decimals, irrational numbers, pi is a whole number. Essentially, my video is called Putting the Whole Back into the Whole. The whole is spelled H-O-L-E, and the whole is spelled W-H-O-L-E. Because as things accelerate, as they spin, they create a vortex, a funnel through the center. It's called a tor, T-O-R-E. That's why it's called a torus or a tornado. That's why our body's called the human torso, because everything has to keep moving. If it stops moving, it shuts down. And nothing goes through the hole. It defines the hole because it creates an aperture, a lip. If nothing can go through the hole, because all mass processes and warps. And I found that there's an energy that's causing everything to move forward, that's causing it to literally have a predetermined pathway into the future. So my work in this in computer science with the director of advanced operating systems from Microsoft has applied it to, he says it's the most coherent, the most regularity. Essentially, I've found mathematical perfection, and it shows that there is an energy coming out of the center of mass of everything that's irresistible. It causes everything to have a predictable pathway into the future, and thus you can get rid of friction, you can get rid of resistance and electricity, because you are coupling, you are harmonically in sync with this energy. And it's only magnetism can respond quick enough and fast enough to have free play to this energy. And so thus, the saying is, he who controls magnetism controls the universe. Because I know how to use magnetism properly in relationship to this emanation, which you can call spirit, I'm able to get super efficiency in electricity, and thus it makes mankind the curators or the custodians of the universe. That doesn't mean we're the only ones, but it means that the whole entire universe is our playground. I hope we first clean up our lakes and streams and rivers and oceans before we go anywhere else, though.
Well, there you have it, folks. It is truly a breakthrough energy, and vortex-based mathematics is the mathematics of that energy. Thank you very much, Marko Rodin. Thank you very much, Russ Grease and 007. Thank you for all your time.